Example 4, find A10 and AN for the arithmetic sequence having A4 equal 18 and A5 equal 22. So recall that the formula that we know for the nth term, AN equals A1 plus n minus 1 times D. Now, we don't know A1 this time. The last one we did, this time we don't. So we're going to have to adjust a little bit, I suppose, and find that A1. Okay? Now, we know A5 is 22, so we can call this A5 here. That would mean n is 5. So A5 is 22, and we're trying to find A1. So now if n is 5, we'll have 5 minus 1 is 4 right there. And then D, do we know D? Well, we do because here's the fourth term, and then they give us the fifth term. It looks like to get from the fourth term to the fifth term, it looks like D is adding 4, right? Go from 18 to 22, you're adding 4. So we've got 4 times 4 in this formula. So 22 equals A1 plus 16. Subtract the 16 over shows me that A1 equals 6. Now, they didn't ask me for A1, they asked me for A10, but now I'm going to be able to use that A1 and figure it out from my formula, because I know that from my red formula, A10 is going to equal A1 plus 10 minus 1 times D. So A1 was 6, right? A1 was 6 plus 9 times D was 4. That's 6 plus 36 is 42. So the 10th term is 42. Now, I guess what you could have done is said the fourth term is 18, the fifth term is 22, the sixth term is 26. You can just add 4, then 30. Then, you could have just counted until you got to A10, but here we're using the formula. You've got 2 different ways, though. Now we want AN. Remember the formula, AN equals A1 plus n minus 1 times D. So A1 was 6, and we don't know n, so just leave it, times 4. Distributive property makes 6 plus 4n minus 4. Collect your like terms, you have 4n plus 2. AN equals 4n plus 2. So again, if you just wanted to use this formula, maybe we should have done this first, then we could have just plugged in 10. The 10th term would be 40 plus 2 is 42. Number 5, suppose that an arithmetic sequence has A6 equal 9 and A15 equal negative 36. Find A1. Okay, so I don't know, it's a little bit harder to find D, I guess, because you don't have consecutive terms. You have A6 and you have A15. But we can go back to our formula again, and we can use that in a different way. Now remember, we've got this. But we can modify it and in this way, okay? We can say that the 15th term is equal to the 6th term plus, and then watch this, you can say the 15th term minus the 6th term times D, okay? Now think about it. If you're going from the 6th term to the 15th term, you're going to end up adding something on 9 times, and that's where that comes in, okay? So we're kind of manipulating our formula in a strange way, but it's not really strange because all you have to understand is to get from the 6th term to the 15th term is we're adding that difference 9 times. So A15 is negative 36 and A6 is 9, and we're going to add on some number D 9 times. So subtract over the 9, you get negative 45 equals 9D, and divide, D equals negative 5. D equals negative 5. Now again, that's not what we wanted. We want A1. So we can go back to that formula. A sub n equals A sub 1 plus n minus 1 times d, and plug in what we need. Okay, we want a1, so let's use a6 here. a6 was 9 is going to equal a1 plus, remember we used n was 6, so 6 minus 1 here times the d was negative 5. 9 equals that's supposed to be a1 plus 5 times negative 5. 9 equals a1 minus 25, and add the 25 over, you get 34. a1 equals 34. Number 6, find a formula for the nth term of the sequence an shown in the graph. What are the domain and range of this sequence? So look at the graph, and we see a bunch of dots, and it forms a pattern. You can see that it's forming like a linear relationship, kind of looks like a line. But let's look at these dots. All right. When x is 1, y is 1. When x is 2, y is 3. When x is 3, y is 5. x4, y7, x5, y9. And so you can definitely see a pattern. It looks like it's increasing by 2. So every y term is going up by 2, up by 2, up by 2. That's your d number, right? D is equal to 2 because we're increasing 2. This, I said an x number, but it's actually an n number. The first number, the second number, third number, fourth number, fifth number. All right? Those numbers we can tell are increasing by 2 every time. So if we want to find a formula, basically they're asking me for the nth term. The nth term is the first term plus n minus 1 times d, or the first term is 1. We're talking about the nth term here, and the d number is 2. So we can clean this up. Distributive property, 1 plus 2n minus 2, or 2n minus 1. And if you think about it, that's exactly what the formula of this line would be if we found an equation of that. 2n minus 1. So then it also asks for domain and range, right? Domain and range, well, that's easy because we know that domain is just the x numbers, right? So in this graph, there's only 5 x numbers. 1, 2, 3, 4, 5, and then the range would be the 5 y numbers, like so.